Okay, nerds, let's get started. Okay, this is going to go into our notebook. It'll be our next notebook page. We're going to talk about light and electrons. Okay, so recall that light is a wave. White light is composed of all your colors: red, orange, yellow, green, blue, indigo, violet. All light travels at the same speed, 3.00 times 10 to the 8th meters per second. Another way of writing this, okay, this is right now written in scientific notation. This 8 here means we're going to move our decimal point 8 spots. 1, 2, 3, 4, 5, 6, 7, 8 meters per second. And that is very fast. Comma, comma. Okay? Speed of all light is in a vacuum is always equal to 3.8 times 10 to the 8 meters per second. Different colors of light have different frequencies and different wavelengths. The speed is going to be measured by, or is going to be marked by the symbol C. Frequency is going to be marked by F, and wavelength will be marked by lambda. Once again, that's lambda. Our equation is C equals frequency times lambda. So let's back up a little bit and talk about what these things mean. Okay, so we're going to draw a wavelength. And we're going to get closer, 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 closer. Okay, go ahead, draw that guy. From here to here, okay, that is our wavelength. Wavelength in lambda, which we measure in meters. Okay, so on this end of the spectrum, we have a very large wavelength. And over here, we have a much shorter wavelength. So here, on this end, we're shorter. Make sure you draw nice and neat. Take your time. And on the other end, this is a longer wavelength. Wavelength. Okay. Now the opposite thing is we're talking about is frequency, how often these occurs. So on this end, remember this is a wave that's moving. Okay. So here we have 1, 2, 3. So in a certain amount of space or time, there's only like 3 of these. Where over here we have 1, 2, 3, 4, 5, 6. There's a lot more. So our frequency, the amount of them increases. Okay. So for frequency, okay, over here we have a higher frequency. And over here we have a lower frequency. Okay? So now these are what's called inverse of each other. As this gets longer, this gets shorter. Okay? As this gets shorter, this gets higher or longer. Okay? That's called an inverse relationship. It's important that the wavelength is always in meters. The speed is in meters per second, and the frequency is in hertz. Frequency will be measured in hertz. Okay? A hertz is any number over a second. Okay? So we're going to write that as 1 per second or 1 second per number. Okay? So let's look at some of these questions. As the frequency of light increases, what happens to the wavelength of the light? Okay? So as our frequency increases, going this direction, what happens to the wavelength? Well, our wavelength becomes shorter. Write this as a full sentence. Okay? So as the frequency of light increases, our wavelength becomes shorter. Next one. What is the frequency of light that has a wavelength of 4.25 times 10 to the negative 8 meters? Okay? So now we got to do some math. Now we're going to be looking at this equation. Okay? We're going to draw our triangle. So in our triangle, we're going to have c, the speed of light, and we're also going to have frequency and lambda. Okay? So for this equation, every time we're doing this equation, we want to cover up whatever we're looking for. What is the frequency of light? This is what we want to know. We want to know frequency. So frequency we end up covering up in our equation. We're going to cover frequency up. We're taking c and dividing it by lambda. Okay? So we're going to take the speed of light, which is 3.00 times 10 to the 8th meters per every 1 second. Okay? And then we're going to be dividing that by our wavelength, or lambda, which is always in meters. Okay? So let's write what we're doing. We're doing frequency equals c divided by lambda. Okay? In chemistry, our math looks a little bit different because we have to account for all the different types of units we're doing. We can't look at just our numbers. Okay? So because we're dividing, we have this line here. This is all one number, 3.00 times 10 to the 8th meters per 1 second. We're going to draw another line, and our next number goes in the next box. If we're going to multiply, the number would go on top, but this is a division problem. So we're going to take lambda and put it down here, because this is division. If it helps you, just draw a little division symbol, okay, because we're on the bottom now. So our wavelength is 4.25 times 10 to the negative 8 meters. Okay? And then we don't have anything in this box up here because there's no per symbol. Okay? So now let's take a look here. We need to cancel out our units. If we take a look at what's on the top versus the bottom, we have seconds, which doesn't cancel out. We also have meters. Okay? 1 meters on the top will cancel out with our meters on the bottom. And now this is a division problem. So this is our first time using these calculators, so I'm going to help you guys out. Okay? We're going to take 3.00 times 10 to the 8th, and we're going to write that as an exponent. So how we do that, you guys can see 3.00 exponent, exp, that's this key down here. Okay? And then we do to the 8th power. Okay? This says 3.00 times 10 to the 8th. That's what we're doing there. And now we're going to divide it by 4.25. 4.25 times 10, which is that exponent key, okay, to the negative 8th. So our negative 8 key is negative 8. What do you get? All right, so here's our answer. So we now have 7.0588 times 10 to the 15th. Okay? Another way of saying this is 7.06 times 10 to the 15th power. Okay, we got to round that. So every time we do this, we're going to have a number. I want 2 numbers past your decimal point. Okay? So this is now 7.06 times 10 to the 15th power. Okay? Now, the most important thing right now, this answer is incorrect. We're wrong. The reason why we're wrong is because I don't have a unit. I got rid of my meters, okay, and I have my division symbol still. This is a number per, what I'm left with is seconds, okay, per every 1 second, okay? And what we already said is any number per a second is the same thing as a hertz, okay? So the other way we can rewrite this is your answer, or 7.06 times 10 to the 15th hertz, Hz. And put a box around it. Okay? Always circular answers. Everything on here should be nice and legible, nice and neat. Take your time with it. Cross out your variables that are different, and we're left with seconds. Okay? Not tacos. Let's try number 7 out. What is the wavelength of light that has a frequency of 3.85 times 10 to the 14th hertz? Okay, so now we're looking for wavelength. So now that we're looking for wavelength, go back to your equation, cover up wavelength, because that's what we're looking for. Okay, and now we have C over F. Okay, so to get this correct, we're going to do C divided by frequency. So for this equation, wavelength equals C divided by your frequency. Okay? So let's start out with the speed of light. Okay? So we have 3.00 times 10 to the 8th meters per, okay, per every 1 second. This is going to be division again. Okay, so our next number has to go on the bottom. Always draw everything has to have a top and a bottom, basically. Okay. And now we need our frequency, which is in hertz. Okay. Now if I put this number down here as hertz, nothing cancels out. Okay. So I have 3.85 times 10 to the 14th. If I have hertz, I'd be left with HZs, meters, and seconds. And we need to get rid of something. Okay. So a hertz is the same thing as 1 per a second, or 1 second per a number. Okay. So our number's down here, which means this gets 1 second. Okay, so let's see what cancels out. In this problem, seconds cancels out, and we're left with meters. Okay, we're looking for wavelength, which we measure in meters, so we know we set this problem up correctly. Let's do this one together too. Okay, 3.00 exponent. Okay, exp. That's times 10 to the 8th power. Okay, and if you had equals, there's our number we saw earlier, 300 million. Okay, we're going to divide this by 3.85 times 10 to the 14th. Divide it by 3.85 times 10, exponent key, to the 14th power. Okay, what do you get? Okay, so we should get, and I want to just type that in again, just to make sure we're correct. We have the frequency 3.00 exponent to the 8th divided by 3.85 exponent 14. There we go. Okay, I got the same thing twice, just making sure I'm right. 7.79, and our 2 says the 9 stays the same. So this equals 7.79 times 10 to the -7th. Okay? And we're going to circle our answer, and that's in meters. We now have 2 problems done. Okay? Let's take a look at it a little bit with energy levels. Next, what we're going to get into is energy. Okay, so now what we're going to do is, if we're talking about these, this is red, orange, yellow, green, blue, indigo, violet. Okay? So red light has a very long wavelength, while violet has a very short wavelength. Red has a lot of lower frequency, while indigo and violet have a very high frequency. Okay, this is our color pattern. We can use this information to look at elements and see what kind of light they're going to emit. And if we do that, we know their wavelength, we know their frequency, and we can figure out the speed of light. Okay. Next, what we're going to get into is energy, but I think we'll save that for the next video.